Hi everyone, my name is Mehdi Barami. I'm going to present Augmented Code. Our goal is learning from natural language description to retrieve the code, more relevant codes. The previous studies focus on abstract of the dog string. This is overview of our framework. We look at the source code and other relevant resources. We parse the content. We generate a list of separate content that we call it code segment, and then we generate the augmented code. That combination of the different features or attribute of the code contribute to the different ACS. In this paper, we focus on the 5 different ACS, and then we generate the augmented code model based on the machine learning that we use the architecture of the code search net architecture and CodeBird. As well as at the end, we have the augmented code model that we can submit any data set and we can search a query and retrieve the results. The goal would be the top rank would be provide better result than current model exists. So what we done? We focus on the code search net data set and we create a different augmented code scenario that we generate different scenario, 5 different scenarios, and based on the different content, and we can look at the content based on different architecture. So we focus on the 2 different architecture, code search net architecture. We use the self-attention and our architecture, and the performance is improved in compared to the original, the baseline, as well as for the CodeBird. So in this demonstration, I'm going to show how it looks like to do this process. So let's assume that this model is the backend of any IDE. First, we need the Code model, which we fine-tune from the CodeBird, which has the outperform our other models. So we publish this content in Hugging Face. So if you look at this link, then you will be able to access the content that include the model in PyTorch as well as TensorFlow. Then you can submit the input user query. So user query is submitted through the script, and then the script generate a list of the batch file. So the first script would be batch generator that generate a batch of options for this query. And once we run, it's generating batch size by default with 1000 record against this query, user query. So once we have this user query and generate the batch size, now we're going to infer to get a prediction that say which code from this batch would provide better performance. So in this case, we're going to run another script that do this process. So currently it's going to run the query against all those batches records so that rank the content. Once we're done, then we have an output. So the output would be retrieve the code and then we return the result. So I already have save file, so I'm going to cancel this and look up the previously generated result. So if we look at the results, on the top we can see the actual content which generated that say retrieved from the list. So it shows the CSV dump is high probability to the save CSV file. So as you can see, it makes sense and reasonable result. It does have, for example, second option that say save SVG is save might be relevant, but SVG Definitely is not, but this is the second option that provide, and then the third one, the fourth one. As you can see, the result is reasonable. Thank you very much for your attention.